Okay. All right. Now look at my to-do list here. I did that. Did that. Did that. How many do I still have that don't have a book? 1, 2, 3, 4. Okay. I am gonna assign some homeworks, but some homework today. So if you all will follow me to the copy room when class is over, I'll print out those pages. You're not gonna need the book enough to be able to have to refer back to it to do this homework. If I just copy the problems for you. Or I can let you take a picture of it. I can't, I'm sorry, I'm old fashioned, I still look up phone numbers in phone books, but we can, if you want me to make a copy, I will make you a copy. If you wanna take a picture with your phone of my book, we can do either way. Just don't let me forget about it, cause I will forget. I appreciate several of you that have emailed me and told me that you're a freshman or junior or whatever, and what you're majoring in and all that stuff. So if you get a minute, do that so I can get to know you a little bit, help me, connect a name with a face. All right, gave the syllabus out. Okay, so today how I'm gonna start is I'm gonna do a little bit of a review. I felt like on Tuesday, we went through a lot of things really fast. So I'm gonna do a really brief review. What we did, for those that weren't able to be here on Tuesday, was we skimmed through the there is a, do they call it prerequisite or I don't think they call it prerequisite, I think that's another word. Preliminary concepts. So we breezed kind of through the preliminary concepts in the book, which is kind of like chapter, I know on the PowerPoints they call it chapter 0, and then we started with chapter 1 and just kind of looked at the very first section. It's 1.1, and the book is organized that way, very, very structured. 1.1, 1.2, 1.3. So that's how I will identify stuff like homework, because I don't know, some of you will have an ebook and some of you will have a paper book, and sometimes if I said page 29, number 7 through 11, and you have an ebook, you're not going to have page. I don't think the page numbers gel. But if I say section 1.1 homework problems, whatever, everybody's will be the same. All right. So first of all, I want to do just a little review, like I said. So, all right. I wonder if this thing sees me right on the board. Can you tell if it does? I mean, if I'm too far away or something.
You're in there.
No, you're okay. I'm good enough. Okay. So we talked about the different forms of reasoning, but the reasoning we're going to use in geometry is deductive reasoning. It is black and white. We are going to have concrete answers to all of our questions. And so we talked about, here is kind of the little reasoning box that they have in there, but if you say, if P, and P is a statement that you really think is true, then Q, and you believe that, this is a true statement, this is a true you could call it a conclusion or a statement, whatever you want to do. But if you believe P is true, then Q will happen, and then you go out in the world, and they don't say it like this, but I'm gonna say, when you observe P, so I'm out in the world, I observe P, therefore, and this little dot, dot, dot means therefore Q. So that is just another way to think about what we're doing. So if P then Q, when you observe P, it's always going to be, you're going to go to Q. All right, and the next thing we talked about it, and then we used it a little bit when we did our GeoGebra problem, is some of our construction tools, and we will build with those. But the 3 basic building blocks that we'll have is we'll have points. So we'll use that. That's one construction tool. We will have lines, which is just a collection of points. A point will be labeled, we'll just call that point A. Usually a line could have multiple points, but usually you're just going to want to identify it by 2 of its points. So this is line AB, and as far as notation, it's in the book, but remember when you're talking about a line, it looks like that. So that's line AB. That could be line BA if you wanted it to be. The other tool that we have is similar, but a little different, and it's a line segment. So it's just a piece of a line, and it's line segment AB. So you would do that in that manner as far as notation is concerned. And we talked about a little bit, we're gonna talk about it a lot today, but we're gonna talk about angles, which is two rays that are connected at their vertex. And, let's see. And then I'm gonna use another color because they do that in the book a lot. Okay, and I know I have a lot of people that wanna be middle level math teachers in here, so are any of you left-handed? Good, well, I am, and it's a real, I'm just gonna tell you, when you're writing on boards with this, you tend to smear your, so, I mean, that's just something that you don't figure out until you get, but never mind, none of y'all lefties, so, good for you. Okay, so we got our point, our line segment, and our, angle, and this can be, I propose to you that there are four different ways that you can reference that angle. Somebody tell me one thing that you could call this angle.
We could call it angle ABC.
Angle ABC, all right. I agree with that. Okay, what's something else you could call it?
CBA.
Angle CBA. All right, what's something else you could call it? Anybody? I know somebody thinks something. How about angle B? What's wrong with that? Call it that. And then last, the hint is that I will use my red marker. What else could you call it? Angle 1, okay. And sometimes, they do those different colors in there just because this notation here just gets a little cumbersome. I mean, ABC, so sometimes they use the numbers in there to identify. None of these are wrong answers. They are all a way to identify that particular construction. One other thing on, so let's see, we got the point, the line segment, and the angle. Remember, that's called the vertex, and I think that's kind of review for you. So notation-wise, there's the line segment, and then the angle notation. You always put the little angle sign in front of it. When you just write AB, what is that referring to? You don't have a line or anything above it. You may not remember, but that means the distance. So it's, in a way, it kind of shifts back to algebra. Geometry, we're talking about all these shapes and constructions. When you don't have any kind of symbol around it, then you're going back to what the distance is between A and B. And let's see. Another big term symbol that we learned was what is, when you're talking about equality in geometry, what word do you use and what symbol do you use? Equality, when you want to say one angle is congruent. So it's congruent is the word, that's the geometric equivalent of equal, all right? And the symbol is an equal sign with a little squiggly mark above it. So when you say angle, I'm just gonna call it angle 1, and if we had one right beside it, if we want to say angle 1 is congruent to angle 2, that means you can set angle 2 right on top of angle 1, and it would fit perfectly. All right, we learned a couple of definitions. Make sure I didn't miss anything from that little. Okay, a couple of definitions, and one reason that I point these out is because just during my time of teaching geometry, these are the definitions you learn at the beginning, and they carry all the way through to all kinds of different proofs. So one definition that we learned that was important was midpoint. And it's important how they define it. And midpoint is the point that separates a line segment into two congruent parts. So it's not the middle of a line or whatever, it separates a line segment into two congruent parts. Also, another disclaimer, everything I say up here pretty much is in the book. I might have a few nifty tricks up my sleeve, but generally speaking, if I say it, the book is really good in it. So don't panic if you don't think you got everything written down. I mean, I'll wait for you, but just don't worry about that. Everything, I'm reiterating what's in the book. So similar but different to midpoint is bisector. So if you have this, so we have this line segment AB, if this is the midpoint M, midpoint is a point, a bisector is a line that goes through M. Now, don't get confused, this bisector could look like that. It wouldn't have to be perpendicular, would it? It just cuts that line into two pieces. So a bisector, it's a line or a segment that runs through the midpoint. Next there were, I can't remember, I wanna say there were about 9 postulates in that first, 1.1. See if that's right. Go to the last one. Now try to nope, we only had 7. I kinda tried to pick up on them, no, actually, no, got 7. Want to pick up the one that are important. The postulate 2 is pretty important, and that is the measure of any line segment is unique and positive. We talked about, you can't measure shapes, their length cannot be negative. That's it doesn't make sense, that's irrational. So all measurements in this class will be positive because you're measuring actual shapes. Very important postulate, I'll put it on the list of importance with these two things, is postulate 3, and I'm gonna abbreviate, I'm gonna call it the segment addition postulate. I'm not gonna write it all the way down. But that's very important, and that tells you, say this is our segment, it tells us AM plus MB equals AB. That seems like it makes sense, but you need to actually say it sometimes in some of the proofs. So the segment addition postulate is very important. And postulate 4 is when you have 2 lines that intersect, 2 distinct lines. In other words, they can't be the same line, because if two lines intersect that are not distinct, they're the same line. But if 2 distinct lines intersect, they only meet at one point. There's only one point where they can meet. If they meet at any more than one point, then they are the same line, and that is postulate 4. Another important, I got 2 more things and we're done. Well, we done with the review. One more important definition that comes out throughout, I think that we have a whole chapter about it, is about parallel lines. And I'm gonna show you the notation. When you wanna write parallel lines, you just write 2 little lines, parallel lines. They're in the same plane and they never intersect. So, this being a plane, the flat 2-dimensional thing, any 2 lines that never intersect are parallel. And we actually learned our first, but we acquired our first theorem. They didn't prove it, but theorem 1.1.1 is the midpoint of a line segment is unique. There's only one point that is in the middle here. Now, do you think the bisector's, just thinking ahead, do you think the bisector would be unique? Is that a bisector? 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 So just kind of thinking outside the box. The point is unique, not necessarily the line that goes through the point. You could have multiple lines that could bisect a line segment. All right, any questions about the little review that we just did? So now what I want to do is just I looked at a few of the exercises in 1.1. If you have your book, it's on page 39. If I can get this to operate good, I'll put them up here. There were just a couple of homework problems that I thought we would do together because they're similar to what the homework will be for today, so that you'll have an idea. This is me drawing.
It was so, I flipped it over and I did it again, I was like, this is so bad.
See what I can get this little thing to do real fast.
I need it ruler, gotta measure it out. Straight in. No, I think this is.
it's actually moving pretty fast, so actually I think, well, why doesn't it have my? I think I'll actually be able to stick the book up here. Maybe. I can. Mark that. All right, I'm gonna move this thing. Well, that's just gonna have to do it. Just, y'all don't miss, because I hate doing this. Okay, that's just gonna have to be good enough. I'll tell you if I'm recording this. Look at the 1.1 exercises. I thought what the ones that we would do, I don't like that. I like this kind of. For these, we'll start with, I'm gonna go scroll down to 15. I hope that 15 is the same as the one as I have. All right, so, given M is the midpoint of AB. Why did I just erase my AB? So we have AB here. And we have our midpoint right here. All right, so if M is the midpoint of AB, and sorry, I'm throwing a little algebra at you, but we will do that from time to time. And we have AM is 2x plus 1. What do they tell you next? MB? Why don't I just look up there? I don't know.
AB equals 3x plus
Okay.
2.
Okay, can we solve for x? Is there a relationship here? AM is this, right? What is the relationship between this and this? They're equal. So, we can set that equal to that and solve for x. So that's what I want everybody to do. Tell me what you come up with. You can set AM, which is 2x plus 1, equal to 3x plus 3. I'll give y'all a minute. Okay, did I write that right? Okay.
The book, I was trying to tell you, the book says, minus 2.
Okay, yeah, that's, I knew there was something wrong. I don't know where I came up with plus 3x minus 2, because I could immediately see that I was fixing to come up with a distance that was a negative number, which was not going to work. Okay. All right, now, so I get, y'all get that, x equals 3?
Yes.
Right. And so then it also asks for the distance of AM. So what's AM gonna be? It's gonna be 2 times 3 plus 1, which equals 7. So we have x equals 3 and AM equals 7. If you haven't done simple algebra in a while, kind of brush up on it a little bit. Don't forget your PEMDAS, what order you do your operations in and so forth. But this is what some of the homework will be, kind of showing you how algebra and geometry and algebra can work together to get some answers. All right, so the next one is 16 up there on the board. And we'll skip that one and I'll let, no, I don't want to do, that's the only other one. No, I want to do them both, never mind. So, let's do 16, I'll let y'all do it, and then I'll do it. You have a book, you can look there if you can't see. Can everybody that doesn't have a book see it? I'm apparently the only one that can see it. The reason I'm doing this is because I don't want you to mess up the distribution with the, so is it 2 times x plus 1? 3 times x minus 2. All right. Did you get x equals 8? Did everybody get x equals 8? All right. And so then it actually asks on this one for AB, which is the complete length of the line. So just find one of them and multiply by 2 or add them together. So, because AB is added together, so I found AM to be 2 times 8 plus 1, so 2 times 9, which is 18, so AB should be 36. And I will leave 17 to you. How would you do 17? Can everybody see it up here? Maybe we do need to do 17. Because instead of setting AM and MB equal, what are we gonna do? What are AM and MB equal to, according to the segment addition postulate? AM is this, right here. MB is this, AB is this. So let's just do this one together as well. Either I'm not making sense or y'all won't say anything. So AM is, on that one, is it 2x plus 1 again? And MB is 3x plus 2. That's where I was getting that the last time, by the way. And what's AB?
6x minus 4.
6x minus 4. All right. How am I gonna solve for x here? This plus this equals this. All right. So 2x plus 1 plus 3x plus 2 equals 6x minus 4. Whatever you gotta do over here, combine your x's and you get 5x. Your 1 and your 2 make 3. Nothing changes over there. Subtract your 5x, you get x. Add your 4, you get x equals 7. And then, so what is AB? 6 times 7, which is 42, minus 4, which is 38. I'll let y'all look at that for just a minute and be sure we're all on the page. I'll actually go do something else. I need to download, no, I keep forgetting to do it. Download all the PowerPoints, so I don't have to do this every time. Okay. All right, everybody okay with the algebra? If you're a little rusty on it, don't worry, the homework problems will get you practiced up on it. So, if there's no questions about 1.1, that's really all I wanted to look at there. We're going to look at the PowerPoint presentation for section 1.2. section 1.2. This is our first official section that we're gonna, as far as have material over there, probably be tested over. All right, so we're gonna talk about line and angle relationships. We've mostly been just talking about lines and line segments so far. Everything that we've said about lines is going to transition into similar postulates and so forth for angles. So, let's see, do I wanna say that? I've already said that, we've already said the point stuff. I'm not flying through, I'm just trying to get something that's important. Am I in 1.1 or 1.2? No, it's 1.0, okay. Forgot how some of this stuff is. Because somewhere it just like defines an angle and all that, okay. Where's that stuff? Maybe I don't like these PowerPoints, because I swear I looked at these and this was not, this is all repeat stuff. Alright, we're just gonna start with this measuring angles. So we're gonna talk about angles. We've already talked about what they look like. We're gonna talk about how we measure them as soon as I can get this to. Of course, the angles measured depends on not the length of its sides, but on the amount of opening between its sides. So it's, this is what we're measuring here. You all know that. Use a protractor to measure. We're not gonna use protractors in here. If we do anything where we're measuring angles, we will use GeoGebra if we make our own, and then most of the stuff in the book is gonna tell you, the measures. Okay, I don't think I need to tell you how to use a protractor. Goodness. Okay. Where is just the list of, no, I don't wanna do any of that, sorry. You know what, I still think that's 1.1. It says it's 1.2, but that can't be right. That's it. I'm gonna look at it one more time. Line and angle relationships. Oh, I know what this is. This is the old book PowerPoints, not the new book PowerPoints. That is because, okay. All right, that's what's wrong with that. I think I can change it maybe. Okay, we'll do it like this. That's the whole thing, that's the whole, I thought I had, I'm sorry, but I could have swore it said it was 7th edition, but it says 6th edition. You see that? It's my fault, I'm going through the 6th edition, I guess. But it says 7th edition right there, and I could have sworn that's what I clicked on. Do y'all see that 7th edition, and I clicked on it? You got me all that 6th edition stuff? Perhaps this will be better. Okay, we're gonna go through the book. We're not gonna, I don't know if it's his computer or what. We'll go through it, we'll just do it like this. Are you kidding me? This is not, still not right. Oh, because now I'm in 1.1. I'm usually much more organized. I'm not sure why this is doing it like this. Okay, that was 1.1 that we've already done. Apparently I know just enough to be dangerous. Huh. I think I'm almost to it. Please tell me this is right. Okay, this is where I want to be, finally. Sorry, last 5 minutes just disregard. We're going to talk about angles in this section. In section 1.2 in the 7th edition book. I have taught from the 6th edition book. I'm not sure why the Cengage people took me to the 6th edition. So we've already talked about angle a bunch of times, but an angle is the union of two rays that share a common endpoint. You call that endpoint the vertex. I think we all know that. Here is the same thing that I just drew on the board about the angle. Similar to, remember the postulate we had about the length of a line segment being unique and positive? Well, similarly, they call this the protractor postulate, and the measure of an angle is also unique and positive. Now, technically, you can go counterclockwise, and get a negative 30-degree angle in general in math, but we're never gonna do that. We're always just gonna have positive angle, positive measure angles. Of course, you use degrees as your unit of measure. It's what we do in here. We don't do radians, all right? I guess I can click on that. Okay, and there's a really nice little table in the book that tells you the different, kind of a little refresher on all the different kinds of angles that we have. And we have acute angles that are less than, right, remember what an acute angle is? Less than what number? 90. And I always think of acute angles as a cute little angle, all right? So they're less than 90. Right angles are 90. Obtuse angles are between 90 and 180. And a straight angle is another word for just a straight line. It is 180. And a reflexive angle actually goes, it hyperextends your angle beyond the straight line. And we will very seldom deal with reflexive angles. We'll primarily be dealing with these first four: acute angles, right angles, obtuse minimally, and straight lines, because we deal with a lot of lines. So that table is right there in your book. Let's see. Is there anything else? All right. Our next postulate is very similar to your segment addition postulate, but this is your angle addition postulate, and it says if a point D lies in the interior of an angle, then the measure of ABD plus the measure of DBC equals the measure of ABC. So let me see if they write that somewhere good that we can see it. All right, here is a figure. Can y'all see that? That's kind of little, isn't it? I'll put it over here. So this is your angle addition postulate. So you have this angle ABC, okay, and they said, so obviously, and here's gonna be the interior, so put M in there. Doesn't necessarily have to be the midpoint, but we're gonna put M in there. And so we're gonna make another angle, so we're gonna go right through M. And so, I should have used red, but anyway, we'll call this 1. Basically, they're saying 1 plus 2 equals ABC. And just like we did earlier, you can call it ABM plus MBC equals ABC. And all the different ways you can say it. But basically, the angle addition, it's really common sense, but it is in the form of a postulate. These two smaller angles are always going to add up to the bigger angle. They're adjacent angles, and I'll talk about that in a minute. So just like two pieces of a line add up to the line, two pieces of an angle, you can break it in pieces and it's going to add up. Okay, I'm going to do that. Next page. I kind of like to get rid of the table. I think I can do that maybe. Not. Oh yeah, okay. So, here are some definitions when you're talking about a particular angle. Two angles are adjacent if they have a common vertex and a common side between them. So, over here, ABM is adjacent to MBC. They have that common line in between them and a common vertex. Congruent angles, we know what that's going to be, don't we? They have the same measure, and you can, congruent angles must coincide when one is placed over the other. So, one other thing that's in the notation. So, when we talked about how we can label these angles, let's just talk about angle 1 right now because it'll just be easier. When I write angle 1, I'm talking about the actual geometric shape. But when I wanna talk about the measure of angle one, I do measure of angle one. So measure of angle one may equal 45 degrees. But, so angle one, measure of angle one, just like we had line segment AB is talking about the actual shape, but AB, when we're talking about a line segment, you're gonna say 7, maybe, whatever. So that's the length, that's the measure, that's actually referring to the shape itself. So just some notation things kinda to get used to. Okay. So 1.2 goes along mirroring everything that we said in 1.1 about lines, we're gonna say in 1.2 about angles, essentially. All right. We're gonna have a bisector of an angle, just like we had a bisector for a line. And a bisector of an angle is the ray that separates the given angle into two congruent angles. Pretty important definition here, bisector. Now, the midpoint concept really doesn't come to play in the angle, because, I mean, there is no midpoint of the angle. Does that make sense? The only thing you have is a bisector. So, you know, when we drew that line up there, you had multiple things that could be the bisector on the line. But how many bisectors do you think there is of an angle? Think about that on this angle. I'll just draw a new one, so we have a fresh angle right here. I'll just draw it like that. And we'll let it be X, Y, Z. ABC always gets to be first. So let's let X, Y, Z. All right, how many lines do you think? How many rays can you draw that will bisect that angle? One. There's only one, and that's gonna be a theorem coming up. So, that's a little distinction talking about the lines versus talking about the angles. Okay. I don't wanna do all that. Okay, another huge concept here is, everybody write this down, vertical. This is something that comes up in proofs a lot, and that's vertical angles. So when you have two lines that intersect, and remember when they intersect at how many points? Just 1 point right there. So these two lines, my line is gonna be, we'll do XY, and we'll do ST. So there's my two lines, and my writing's not very good, but, so they're gonna they're going to intersect or meet at this 1 point right here, what we're gonna call that point Q, okay? All right, so, there's no red pencil. So we got some angles here that I wanna talk about, and I wanna talk about, do them like this, 1, 2, 3, and 4, okay? 1 and 2 are what you call vertical angles, right? When two lines cross, the ones opposite are vertical angles. 3 and 4 are vertical angles. Okay. Vertical angles are congruent. So this means angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. What does it tell us about their measures? The measure of angle 1 equals what? Measure of angle 2. And the measure of angle 3 equals the measure of angle 4. Okay? What do we know about the relationship between 1 and 3 that we just learned a word for it over here? I'll just tell you. My kids hate when I ask them a question and I tell them the answer without even giving them a chance to give the answer. So if you know what you call 1 and 3 angles, speak now. Adjacent angles. So they're side by side. You know, they share that. So you don't really always think of a line as an angle, but it actually is just a 180-degree angle. And so 1 is adjacent to 3, 3 is adjacent to 2, 2 is adjacent to 4, 4 is adjacent to 1, etc. So vertical angles is kind of a pretty important, concept, and that will be used, to, prove stuff later on. Let's see. I think there's just one more little concept here, and that is complementary and supplementary. What, did I pass it? Did I go so fast that I skipped complementary and supplementary? I bet I did. Does this thing have page numbers on it? I don't know, I could've swore. Well, complementary and supplementary in the book are on the bottom of page 43 and the top of 44, right before, I don't know why I can't find them in this book. Okay, classifying angles. I've already said adjacent, I've already said congruent, I've already said bisector. Oh, here, sorry, I went too fast. See, I told you I talked too fast. So, these are just terms to learn. I mean, it's not all that important, just to know what complementary means, and supplementary is. Complementary means I add to 90, supplementary means I add to 180. Now, a girl in one of my classes, a girl named Angel Blair taught me this in my classes. To try to remember which was 90 and which was 180. So 90, when you take complementary, you can turn that into a 90. And when you take supplementary, you can turn that into a 180. That's one way to remember it, or you could just remember it. I don't know. So complementary adds to two angles that are adjacent, add to 90. Supplementary are two angles that are adjacent but add to 180. And then lastly, we will have our second theorem that we will be introduced to. And I've already alluded to it, we discussed it, but I gotta find it, because I think I passed it too. Oh, it's on next page. Okay, and this theorem 1.2.1, so we got 1.1.1, which is about the midpoints, and then on 1.2.1 we have there is one and only one bisector for any given angle, or for a given angle. So every angle just has one bisector. Another way that you can word that statement is the bisector of an angle is unique. Okay, so I'm gonna assign some homework. We're gonna do a couple of them. I'm gonna do some even ones for you so that you have a pattern to go by. And then we're gonna do GeoGebra. We're going to construct a congruent angle from a given angle. And so your homework for section 1.2 should be on your syllabus, and it is 16 through 24, as in all of them, not odds. And in a minute, when we get ready to leave, some of you that want to take a picture, it's just 2 pages. But the ones that are a little tough are the ones with the fractions in them, and then there are a couple with 2 variables in them. There's some examples in the book, but we will do, what did I say the homework was, 16 through 24? I am going to do, I thought I would do a fraction one for you, so I thought I'd do 22 and 24 is what we're gonna do it in class right now. So y'all can start writing down number 22, see what you can come up with. We'll look conceptually at it, and then we'll solve it. So, I would pray to help you people that don't have a book. I bet I could put it up here. Next page is. If I could make that bigger, I hadn't figured out how to do that yet. I'm sure one of you smart people can tell me. Zoom, there we go. How about that for making number 22 bigger? Is that okay? Alright, that's the first problem we're gonna do, but I'm gonna draw a picture of it too. So we know what we're talking about. So we have this big angle, RST. Okay, and so, is V the thing in the middle? Nope, it's RSV and T is in the middle, RSV is in the middle. So it tells us the measure of angle RST, ooh, now I can even see that, equals 2x/3. And it tells us the measure of angle TSV equals x/2. And it tells us measure of angle RSV equals 49 degrees. We got those three pieces of information. How are we gonna find x and then TSV? So we wanna find x and measure of angle TSV. So what do we know about the relationship between RST? And I think it tells us one more thing. Does it tell us something about it being the, let's see. Does not tell us anything, any midpoint stuff, does it? I thought maybe it did. Okay, no. Okay, we just know these are side, we do know this. We know this plus this is gonna equal this. The two pieces are gonna equal the whole, right? And, so we know the whole thing is gonna equal 49, so would you just not take that and add that and put equals 49? That sound logical? So we're gonna say 2x/3 plus x/2 equals 49. I've made enough math mistakes to know that I'm gonna look, I already have done this once, so I will look at the answer to be sure I don't. Okay, all right, there are any number of different ways that you can do the math on this. So if you don't do, if I don't do it the way that you do it, that's fine. Do it the way that is most comfortable to you. I would probably multiply both sides of this. I'd actually probably find, what I did was I thought, first I was gonna say I was gonna multiply both sides by 6, but then I looked at 49, I thought, no, I don't wanna multiply 49 by 6. So I'm gonna find a common denominator on this side, which is 6. So I'm gonna put 6 down here. I'm gonna say 3 times 2 is 6, 2x times 2 is 4x. 2 times 3 is 6, 3 times 3x is 3x. And that's what I'm gonna do. And then I'm going to say 7x/6 equals 49. And then I'm gonna multiply both sides by 6/7. That's what I would do next. So I'd say multiply this side by 6/7, multiply this side by 6/7. So that'll get rid of your, leave with just x over here. Now I'm gonna get to divide my 49 by 7 and get 7 times 6 is 42. So I get x equals 42. And so then what is the measure of angle TSV? Isn't it x/2? Which equals 21 degrees. Now notice just a tiny distinction here. When I asked you to find x, I was just asking you to find a number. But when I said the measure of an angle, you wanted to add the little degree sign there. So just a tiny little distinction. I'm not going to give you a problem with fractions this hard on a test, but I want you to know that it's out there and you need to know how to do it, but it'll be more simple than that. So don't panic if you don't do the math the way I did it. If I were you, I would start with this, right here. This is what you're trying to solve, right here, and do it your way. Whatever way that you're gonna solve for x with this. You don't have to do it the way that I did it. And I know I skip a lot of steps. I've been doing algebra for a long time. I do a lot of 24 is the other one that I wanna do, because it has actually got two variables. And, as I said before, I think there's some actually examples in the book like this, but now you've already got one homework problem done, see? So now, when I do this other one, you'll have two homework problems done. So, I'm at, I need to, next page, oh, no, okay, 24. I keep forgetting, I got a lot of things going on here. I tried to remember everything, okay. So this time, we have an extra piece of information which is very helpful, and that is that ST bisects RSV. So then what do we know about these two angles right here? If this bisects them, what about these two? They're equal, yes, okay. So RST is 2x plus 3y. That's that there and we're 2x plus 3y. And then, TSV is 3x minus y plus 2. And then RSV, the whole thing is, I've got 80 degrees. Okay. So, how are we going to set this up algebraically? When you look at these, if you remember back, there's not gonna be any way to like add them or subtract them together and eliminate them. You're gonna have those two dumb variables the whole time. So what I recommend doing, and that's why I'm not asking you to do this, I'm gonna show you how I would do it, is I would, set them equal, and then, I gotta not do number 20, I do this. Set them equal and then solve one in terms of the other. Ooh, I picked up. What am I doing? 24? Why did I pick that one? Okay, so 2x plus 3y, we know is gonna be able to equal to 3x minus y plus 2. There's nothing essentially that you can do with that. But you could add them together and get 80, right? So, what I'm gonna do is I'm gonna try to get this down to one variable and set the whole thing equal to 80. How am I gonna get that down to one variable? Well, the easiest way to do it is I'm gonna subtract 3y, okay? So, when I subtract 3y, I'm gonna get 2x equals 3x minus 4y plus 2. And I'm almost there. Now I'm going to, we're gonna put the 3x over there, okay? Because you want to isolate the x. You can decide to isolate the x or the y. So I'm gonna subtract 3x over here, and I'm gonna get negative x equals negative 4x plus 2. And then you could go with that, but I'm gonna multiply both sides by -1 so that I can flip that. I don't like to deal with negatives, so if I multiply this whole thing by -1, I'm gonna get x equals 4x minus 2.
4y.
Oh, yeah, I meant y. You gotta be able to read my mind, just 4y minus 2. Where did I lose the y? Right here. Okay. Don't panic if this is a little above your comfort zone in terms of algebra. They're not all gonna be this hard. The only reason I'm doing this one for you is because you're gonna be doing them by yourself. The first ones will be real easy. These last few will be the only one that's hard, but this is real algebra that you've probably all done in college algebra. I'm not sure how long ago it was. So now I can take, minus y plus two equals 80. That really looks a lot more complicated than it actually is. First thing I would do I would be go through and get rid of all the parentheses. So I would get this one down to 8y minus 4, plus 3y, plus 12y minus 6, minus y, plus 2 equals 80. When I get a big long string like this and you're trying to find like terms, I'm gonna start I'm gonna find all the y's and add them up. So, and I'm gonna put a line number. So I got 8y, I got 3, that makes 11, plus 12 is 23, minus 1, so I get 22y. What do I left here? I got negative 4, minus 6 is negative 10, plus 2 is minus 8. I'm making sure we did the math right. So I got negative 4, negative 6, minus 10, plus 2 is minus 8, equals 80. And when you get into that, it's easy. You got 22y equals 88, y equals 4. Once you know y equals 4, what's x? 16 minus 2. 4 times 4 minus 2. So x is 14. And then that actually is all it's asking for. So, like I said, don't panic if the algebra on this is a little bit above your comfort zone. All the algebra is not going to be like this. These are just kind of the two harder ones, and I thought I'd do them for you. So, if nothing else, you have 2 homework problems. So the rest of the problems will be due on Tuesday. And if you have trouble with them, I'll work with you on the first of class, and we'll do them if we need to. Now, get your iPad ready, and we're going to do GeoGebra, and then it shouldn't take us at 6:02. I bet we can get it done in about 6:10.
What did you say the homework problem again?
16 through 24. Okay, and I've already done 22 and 24.
So is GeoGebra an app or is that a website?
Either. I mean, I go to the website, I think you can download the app for free.
Can you write the website on it more?
I don't know, I just search for GeoGebra and see what happens.
Yeah, just look up GeoGebra geometry and it should be the first thing that pops up.
Alright. Well, recently, okay, so should
This is the first thing that pops up. Nope, that's not right. Go back to Google.
what app are you, I mean,
Look up GeoGebra geometry. If you don't type in
It's
geometry.
on the
it brings
iPad,
up
so
something really long.
I just downloaded it.
it may be, okay, GeoGebra and geometry.
First thing that pops up.
Well, that's not it, it's the web, Wyzan, that can't be it, it's got, you're gonna have,
That's it.
you know, it should be something to do with GeoGebra. Let's see, just keep on. Go to okay. That's it. Okey dokey. Now, where do I wanna go? Where's all my stuff? I forgot, is this mine? I wonder if this one works, I can't remember. Okay, so we are doing construction 3, which is on page 46 of your book. And it is construct an angle, oh, this is the wrong one, sorry, Right. I tried this thing on here, that's not right, never mind. Get out of there. 16 isn't looking too good if I can't do this, get this to do, that's the wrong one. Where's my little bar up here that has all my favorites or whatever? See, I wanna get out of all this. But I thought I had some favorites somewhere. I saw them. Bookmarks. No, not in that.
Go back to the 3 little dots you
I'm
pressed.
starting over. Sorry.
It was in there.
It was up here when I first got up here, and then I put all that other stuff on it. There it is, GeoGebra. And I didn't save my darn settings, so I'm gonna have to get my, okay, I would not have the axis and I would not have the grid. No grid. Okay, all right. So the first thing we're gonna do is make an angle. I would prefer you to make an acute angle. And so this is how we're gonna do that. Where you have your tools, it should say basic tools, And if you click on more, there should be a tool to make a ray somewhere down there with lines. See, so click on the ray button and do your bottom part of your ray, and then click on the A again and get you an angle about like that. So tell me if you got an angle like that. Okay. All right. That's all good, except my B is way too far out here, and yours probably is too. I can just tell you right that. So we're going to make this little circle. So just leave your, there's a bunch of different ways you can do this. We'll do that other in a minute. So we are going to go take our compass tool and make a circle, but we don't have an end point over here. So first thing we're going to do is, we could use the B that we already have, but can you see that if I use that B, I'm going to have this giant circle, but if I can put a point over here closer to my A, I'm going to have a little circle. So that's all I'm talking about. So I'm going to put another point that's closer to my A, about right there. That's a D. That's the only reason I'm doing that, because as soon as I tell somebody to draw an angle, they do this big angle, just like I did. All right, now I am going to make a, use my compass tool, and I'm going to make a circle related to A and D. All right, you'll see what I'm going to do. AD is the radius of the circle I want to make, and I want it centered at A. Okay. Now I'm going to mark this point where my new circle intersects my angle. So I am trying to recreate angle CAB down here below. So everybody should have something that looks like this. And as you see this right here, do you see this point? I mean, I don't have a point there yet. Where they meet up, if you'll click on your point tool and make a point there, then everybody should have something that looks like that. And I'll give you a minute, okay? All right. So if it were me, well, it is me, I'm going to hide B and C, just for one thing, to practice toggling with the algebra stuff. But if you click on that button that looks like a calculator, get rid of that B and C, and by that I mean hide them. So there's just a bunch of points on there. We don't need them for anything. I'm going to hide B, and I'm going to hide C, just so that we can kind of see the angle that we're recreating right there, okay? Okay, to make another angle, we're going to do it below. And the first thing we're going to do is just draw a line, okay? A ray, I'm sorry, we're going to draw a ray. You could draw a line, but we're just going to draw a ray, kind of a straight ray. So I'm going to make a ray down here, and that'll be the base for my, and I would make this other point way out here. So that's the base of my angle. So what this is what we're doing. See this angle EAD? We're going to make exactly the same angle here. It's going to be, I don't know what variable that's going to be, but whatever it is, that's the angle. We're going to make it exactly the same. So how are we going to do that? The first thing we're going to do is we're going to take this big circle up here, and we're going to put one just like it right here. So go to your compass tool, okay, and it's this circle right here. It's the AD circle. So you want that to be the radius of your circle, but you want to drag it down to F. Okay, and as you can see, this spot right here, this point is going to be the same as D, so we want to mark that with the point. So where the circle crosses our new base for our angle, we want to put a point there. Okay, so can you kind of see that AD is really the same thing as FH right now? Okay, who thinks they know what we're going to do next? The question is, do I know what we're going to do next? But I practice, so I do know. So now we're going to take D, the relationship between DE, we're going to make a circle centered at H. It's going to intersect this other circle, and that's going to be our other spot. So let's walk through that. We're going to use our compass tool again. And now we're going to do circle DE, but we're going to drag it over here by H. Click. Now you see where a big circle intersects with a little circle, okay? At that point of intersection, put a point, okay? All right. So it's going to be angle IFH. And now you can either put a segment or a line connecting F and I. I'm gonna do a segment just because I want to. Doesn't matter, or array I meant, okay? And now, I propose to you that EAD is congruent to IFH. What I want to do before we measure it is clean it up a little bit. I'm gonna get rid of all of my circles. So I'm gonna go to my calculator button. I'm gonna get rid of that first circle, or whichever circle that was. I'm gonna get rid of that circle. Everywhere you got a circle to where you just are looking at some nice angles. Now it's kind of easier. Now I kind of wish I'd done a whole line there, but. So everybody see, everybody got an EAD and an IFH? Go back to your tools and there's a measurement section. You wanna measure an angle and EAD. If it's not the same, mine is 33.5. I'm gonna measure IFH and it's 33.5. Thank goodness. So, the measure tool is, just keep scrolling. And that's it. I'm gonna come around and look at your iPad if you're ready for me, and if that is be your first grade, I'll get it put in VCamp tonight. And we're adjourned. If you need some help with the GeoGebra, let me come around and look. If you're fine, also if you need to take pictures of homework problems too. Are you good with yours? Okay, I'll help you in a minute. You good with 2 angles? Oh, it measured the reflex angle. For some reason. See how that was going today?
I think I made like 12
I don't know why I
circles.
did that.
I was like, what am I doing?
Did you get EAD?
Yes. Yes. And she was like, what are you doing?
Go to EAD and see.
Are you going to the No, I have to go to work. I'm going to tell them. And I'm only gonna be there like 3 hours.
Okay, I don't know why it's not, oh, you might have lost your line, I'm not sure, but that's not looking, that's close.
I've been up to.
Okay, you got 2 that are equal, okay, you're good to go, you're good to go, you can take pictures, have you measured yours yet?
Do I need to take?
You're good to go,
No, I gotta do pictures. I was like,
okay, I'll hang around, I just want the people that, I haven't, you haven't measured yet. Yeah, see, that measures that. Yeah, something that's right. Are yours the same?
I don't know how to change that.
Okay, all right. All right, if you want, if you're fine, go ahead, if not, we'll start from scratch and do it one more time.
like this.
I'll see everybody. And I'll set the book over here to the corner. And I would just take a picture of page 47 and 48. And, okey-doke. And I'm turning off this